What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A+ 1201 certification exam. So let's get into it. Let's talk about storage. And we're not talking about the type that you rent to hold your extra furniture, but the kind that powers your computer and holds your files, applications, games, and your pictures. So if you're studying for the CompTIA A+ 1201 exam, I'm going to break down storage devices in a way that actually makes sense so that you can successfully pass this test. So with that being said, let's go. First things first, what is a storage device? Well, in simple terms, a storage device, this is any piece of hardware that holds data temporarily or permanently. There are two broad categories. You got what is called primary storage, like your RAM, and this is a temporary data storage solution that loses data when the power is turned off. And you have secondary storage, like your hard drives or your SSDs, and this is permanent data storage that holds your data even when the power is turned off. Now, we're going to focus on the secondary storage for this video, such as internal drives, removable media, and drive configurations like RAID. So with that being said, let's get into it. All right, so let's talk about hard drives or HDDs. And basically, these things use spinning metal platters and a magnetic head, kind of like an old school record player. And your data gets written to and read from these platters. And within that, you have what is called a spindle speed. Now, the spindle speed, this is measured in RPMs or revolutions per minute, and this tells you how fast the platters spin. So basically, the faster the platter moves, the quicker you can access your data, at least in theory. And when it comes to the spindle speed, you got 5,400 RPMs, and that is slower, quieter, energy efficient, and you'll find this using laptops or backup drives. And you got 7,200 RPMs, and that is very fast, and you'll find that used in common desktop PCs. And then you got 10,000 RPMs, and this is used in performance or enterprise systems, but this is not very common now due to SSDs. And then we have the form factor. So remember, form factor, this equals the physical size. You got 3.5-inch HDDs, and this is typically used in desktops and servers. Then you got 2.5-inch HDDs, and this is commonly used in laptops and portable external drives. Now, even though the 2.5-inch size is more compact, it can still be used in desktops with an adapter. All right, so let's move on and talk about solid state drives or SSDs. Now, SSDs, these are the new kings of the storage world because they have no moving parts, they're faster, and they're more durable, and they're more expensive per gigabyte, but the speed is still worth it. And within that, we have various communication interfaces, and this is how the SSD talks to the rest of the computer. And there are several major types. The first one is called SATA or serial ATA. Now, this is older, but it's still in use. It's slower than what is called NVMe or PCIe. It usually caps off at around 550 megabytes per second. It is compatible with most systems, and it comes in a 2.5-inch form factor or mSATA. Then we have what is called NVMe or non-volatile memory express. And this uses PCIe lanes to transfer data super fast, and the speeds can exceed up to 3,500 megabytes per second or more. And this is great for gaming, video editing, boot drives, and this only works if your system supports it. And it typically comes in the M.2 form factor. If you look on your screen right here, this is the NVMe M.2. Yes, it is pronounced M.2 form factor SSD hard drive. Then there's this thing called a PCIe or the Peripheral Component Interconnect Express. And this is basically the highway NVMe rides on. SSDs, they can also be on expansion cards that are installed into the PCIe slots that you can see on your screen right here. And this thing supports very high bandwidth. And you have what is called SAS or Serial Attached SCSI, SCSI. And this is mostly used in enterprise level setups. And this is used in servers or high performance workstations. It's more robust and faster than SATA, and this supports multiple devices on one connection. All right, so let's quickly talk about the SSD form factor. So once again, we got what is called M.2, as you can see on your screen right here. And basically, this is a thin hard drive that you stick directly onto the motherboard. And it can use SATA or NVMe, so you want to look at the key notches to tell the difference between the two. And this is popular in ultrabooks and gaming laptops. And then you have what is called mSATA, which stands for mini SATA. And this is used in older laptops, and it's smaller than the 2.5-inch SATA drives, but they have now mostly been replaced with the M.2 hard drives. All right, so let's move on and talk about drive configurations. And within that, we have a concept called RAID, RAID, and that stands for redundant array of independent disks. And sometimes you'll see it referred to as redundant array of inexpensive disks. But either way, this is a way of combining multiple drives to improve speed, reliability, or both. Here are the most common types that you need to know for your exam. So you have what is called RAID 0. This is also known as striping. And this is basically when the data is split across two or more drives, and this provides faster performance, but it does not provide redundancy. So if one drive fails, you're going to lose everything. But this is good for speed, just not for safety. Then you have what is called RAID 1 or mirroring. And this is when your data is copied exactly to two different drives. So if one fails, you still have the other drive to go to. It provides redundancy, but it does use double the space. And this is great for important data that you do not want to lose. You got RAID 5, and this is called striping with parity, and this needs at least 3 drives, and this combines speed with redundancy. So if one drive fails, you can recover data using parity, and this is more efficient than RAID 1. You have what's called RAID 6, and this is striping with double parity. So this is like RAID 5, but it adds extra parity, and this can survive 2 drive failures, but it needs at least 4 drives to operate. However, it does provide slower write speeds due to the extra parity. You have what's called RAID 10, which is a combination of RAID 1 plus RAID 0. This is also known as mirrored stripes, and this requires at least 4 drives. This is fast and fault tolerant. However, it is expensive, but it is effective. All right, so let's go ahead and talk about removable storage. And these are the kinds of storage that you can take with you in your pocket or slide into your camera or phone. And the first one we have is called a flash drive, or the classic USB drive. This thing is small and portable. It uses flash memory like an SSD. It plugs directly into USB ports. This is great for quick file transfers, bootable media, or temporary backups. However, the downside is it's easy to lose these things. They have a limited lifespan, and the speeds can vary by the versions that you're using. And then we have memory cards, and these are used in cameras, drones, and some older phone models, and a whole bunch of other stuff. But the common types that you have are SD, and that stands for secure digital. You got what is called micro SD. This is used in smartphones and some type of action cameras. You got what is called CF, or compact flash, and this is more for professional photography gear. But overall, memory cards, they are great for portability and expanding storage. However, just remember that they can be small and fragile. Next, we have what is called the optical drive. Yes, optical drives, they do still exist, even though many new laptops skip them entirely, meaning you're not going to find a CD player on many new laptops these days. But in the event that you do come across these things, these are the types of optical drives that exist out there. You got CDs or your compact discs, and they can store up to 700 megabytes of data. You got what is called a DVD, and that stands for digital versatile disc, and this can support up to 4.7 gigabytes of data on a single layer. You got the infamous Blu-ray DVD, and this can support upwards of 25 gigabytes of data on a single layer, and obviously it can support more with dual and triple layers. Now, the common use cases, this is used for installing older software, watching movies, archiving files, or burning data if you're using a writable disk. And then you have read and write capabilities, and within that you have what is called ROM, or read-only memory, and this is basically pre-recorded data. You have what is called R, or recordable, and this is where you can write data to a disk once. We have the RW, or rewritable, where you can write data to the disk as many times as you can before the disk just completely breaks down. All right, so here is a quick recap of everything that we just talked about in a nice side-by-side comparison, talking about HDDs, SSDs, RAID, USBs, memory cards, and optical drives. So go ahead and get a screenshot of this in your life so you can use it to help you successfully pass this exam. All right, so let me go ahead and wrap all this information up. So here are some tips to help you pass this test. You want to know your form factors. You want to understand that M.2 does not equal M-SATA, and that does not equal 2.5-inch form factor. Do not confuse SATA with NVMe. SATA is slower and uses different signaling. Also understand the differences when it comes to RAID. RAID 0 means you can save and write data really fast, but it offers no redundancy. RAID 1, it provides safety, but it slacks on the speed compared to RAID 0. And RAID 5 and 6, it provides some type of balance. M.2, you can use either SATA or NVMe, depending upon the motherboard and the drive. And optical drives, they might feel ancient, but they still show up on your test. So when it comes to storage, there is no one size fits all. If a gamer wants speed, they're going to go with the NVMe hard drive. A photographer who wants portability, they're going to go with memory cards. And a budget conscious user, they might just stick with the big 2 terabyte hard disk drive. Your job, both on the exam and in the real world, is to understand the strengths and weaknesses of each storage type and know how to use them. All right, so with all of that being said, let's do some check on learning. So our first question is, which of the following storage interfaces offers the fastest data transfer speeds for solid state drives? Would that be SATA, USB 3.0, NVMe, or mSATA? And the correct answer is NVMe, or non-volatile memory express. And this uses the PCIe bus to deliver extremely fast data transfer rates, significantly outperforming SATA and USB interfaces. mSATA, this is just a form factor that uses the older SATA interface. Next question. What is the primary disadvantage of using RAID 0 in a system? Is it has slow read and write speeds? It reduces the total usable storage capacity. It offers no fault tolerance, so if one drive fails and all the data is lost, or it requires a minimum of 3 drives to implement. And the correct answer is it offers no fault tolerance, so if one drive fails and all your data is gone. So RAID 0 stripes data across multiple drives for performance, but it does not provide any redundancy. So if one drive fails, the entire RAID 0 array is compromised, and it only requires a minimum of 2 drives to set it up. And our final question is, which of the following form factors is most commonly used for NVMe SSDs in modern laptops? Is it the 3.5-inch form factor, the M.2 form factor, the 2.5-inch form factor, or the mSATA form factor? And the correct answer is M.2. So M.2 is the modern compact form factor that supports both SATA and NVMe interfaces. NVMe SSDs in particular are often found in the M.2 form because of their compact size and adaptability to deliver ultra-fast performance via the PCIe interface.